In the previous video, we had the introduction to states of matter. In this video, we are going to be talking about intermolecular forces. Before I talk about what the definition is and what are the various types of intermolecular forces, we need to understand this. There are two types of molecules, polar molecules and non-polar molecules. And this concept is very important for us to understand intermolecular forces properly. So polar molecules, before I tell you, okay, fine, this is a polar molecule and this is a non-polar molecule, let us look at like examples of polar and non-polar molecules. So polar molecules examples include, or rather one of the examples or most commonly known examples is water. So water is polar in nature, and this basically means this is polar because of the fact that between hydrogen and oxygen is more electronegative, and so what happens is this bonded pair of electrons get pulled towards the oxygen. This leads to the formation of something called as a dipole. So we know oxygen is more electronegative than hydrogen. Because of that, it's able to pull the electrons towards itself, and this in turn creates a partial negative charge on oxygen and a partial positive charge on hydrogen, or rather both the hydrogen atoms. Non-polar molecules, on the other hand, do not have all of this happening. So they generally don't have a dipole. So examples of non-polar molecules could be chlorine molecule, hydrogen molecule, and even carbon dioxide is considered non-polar. This is because the dipole is on the opposite sides. Oxygen is more electronegative than carbon, and these two generally cancel each other out. So carbon dioxide is also considered non-polar in nature. So here these molecules, on the other hand, both these atoms have equal electronegativity. So the electrons are shared between these two atoms equally, whereas if you have a non-polar molecule, in a polar molecule, you have a more electronegative atom that tends to pull the electrons towards itself. So the reason we're talking about polar and non-polar, and one more thing before I start that, non-polar molecules or atoms rather also includes noble gases or inert gases. So the reason we're talking about all of this is because in intermolecular forces, the topic intermolecular forces, the whole concept about polar and non-polar is very important. So first of all, intermolecular forces are defined as the forces which are present between atoms, or forces of attraction or repulsion. This includes both attraction as well as repulsion, and these are the forces between atoms or molecules. Now this does not include things like our bonds which are formed, like for example, you have sodium and chlorine forms sodium chloride. This is an example of an ionic bond. Here you have a bond between two ions. On the other hand, this also does not include a bond formed by sharing of electrons. So when we have a bond between chlorine and a chlorine atom, we're not talking about the attractive force between the two chlorine atoms. Okay, that's not what we're discussing over here when we talk about intermolecular forces. On the other hand, it's about the intermolecular forces between the atoms or between the molecules. It's not the bonds which are formed. So as I told you, it's divided into polar and non-polar. Now the reason all of this is important is because when scientists were trying to convert non-polar gases to liquids, they were able to liquefy it, but they were trying to understand what are the various forces which had come into play. And Van der Waals was the first, Van der Waals force was first proposed by a Dutch scientist, Johannes van der Waals, and he studied the effect of various forces on the behavior of gases. So the intermolecular forces of attraction is actually quite weak And they in turn make sure that gases as liquids have low melting points and boiling points. So the intermolecular forces are basically due to four different interaction types. The first is dispersion or London forces. The second is dipole-dipole forces. The third is dipole and induced dipole forces. And the fourth is hydrogen bonding. And we'll be discussing all of this in the next couple of videos.